This brings us to the final module, module 13 on late Homo. It's going to cover heidelbergensis, Neanderthals, and us, right? Anatomically modern Homo sapiens. Heidelbergensis is a big problem. It's also been called archaic Homo sapiens, which is even more confusing. Basically, we've got a bunch of creatures that are intermediary between Homo erectus and us and Neanderthals. And it looks kind of difficult to classify. And it's getting even more challenging in the fossil record as we go along because new fossils are being found that are hard to describe. So let's try to discuss this, what's known as the muddle in the middle, Homo heidelbergensis. Homo heidelbergensis, or Heidelberg man, the type specimen actually is very poor in terms of representation. You can see it's only a mandible. It's only the lower jaw of Heidelberg man. More recently, we found more stuff that can be attributed to a general morphology that is found in Africa, Europe, and Asia. So you can find Heidelbergensis fossils as old as 800,000 years up until even about 130,000 years. Otto Schodensack was probably one of the first people to describe the Mauer mandible in 1907. And we're finding a whole bunch of other material. You may see material in the news about the Denisovans. There's another one, a specimen recently found, if you want to look it up, known as Dragon Man. We're trying to figure out where they fall on the tree of human evolution, and I'll do my best job here. So you notice with Homo erectus leaves Africa and has a footprint there, as well as parts of Europe, as well as Asia. But when you look at Heidelbergensis, now we've got, you know, hominids all over the place, including Europe. Heidelbergensis specimens in Africa, Asia, and Europe, they all look very similar, but they have very subtle differences in each continent. This one is from Africa. This was found in Zambia, 600 to 200,000 years old. You can see that they usually have a very large nose, a nasal aperture. They have typically a longer low skull like Homo erectus and not much of a forehead. They usually have a brow ridge. Look at their brow ridge. It looks like they have bony eyebrows. They have arches over each eye. And we see this very similar, the nose and the eyes, in generally in all parts of the world during this time. Here are some of those characteristics in greater detail describing them. They have a large nasal aperture or nasal opening. They have a supraorbital torus or brow ridge or arch on each one of their eyes, each one of the eye orbits. A much more rounded brain case in comparison to, say, Homo erectus. And now we have a cranial capacity which is on par with some, modern Homo sapiens, about 1,200 cc's. If we compare Africa to European archaic Homo sapiens or heidelbergensis, you've got the one from Africa on the left, and this one on the right is actually from Greece. You can see that, again, generally the morphology is similar, but with subtle differences. What's really neat is that in Europe, we actually have the traits that link heidelbergensis to Neanderthals. So Neanderthals have an occipital bun. Neanderthals also have midfacial prognathism. And you can see this on specimens in Europe here on the left and the right. And so we have a clear link of heidelbergensis evolving into Neanderthals in Europe based on the fossil record. Heidelbergensis also is notable for a stone tool technique known as the Levallois technique. It's a French term, and it actually is a way of producing a number of different stone points out of one single core. Now remember, Oldowan tools, those are bashing two stones together to hopefully get a sharp implement to solve a problem, right? Cutting meat off of bone, shaving meat off of bone, for instance. And Acheulean tool is a hand axe. It's a composite tool. It's made out of the core. But when you look at Levallois technique-based tools is you can see in the image here, steps 1 through 6, you start by removing the outer cortex of the core, right, the outer sheath, to get the nice smooth stone on the inside, good fine quality stone. And then you create a platform where you have a prefabricated point, right? It's kind of like Eidolon technology, but you're seeking out where that point is on a platform of the core, and then you have one major strike to nap it or knock it off. And you do this several times to try to make as many points, stone points you can out of a single rock or core. And this is probably one of the earliest methods of mass production. So mass production or mass producing stone tools out of one single core.